Awesome. So we are gonna check out the next part of this workshop, which is working with a weather database. So you're gonna wanna, in the SQL Workshop directory, you're gonna wanna navigate into this directory weather that's inside, it's just right inside the SQL Workshop directory. And you're gonna wanna open up the lessons file in there. And this is what we're gonna walk through for this for about the next 20 odd minutes. And then we'll do we'll talk about resume coaching and stuff and maybe take a break and then do some more coding. So I'm just gonna kind of burn through some of the setup steps here and kind of start getting to the good stuff. So I'm going to create my database from the command line again, and I'm just going to call it weather. I'm going to go ahead and run this psql-f command that will tell psql use this file, run all this SQL against the weather database. And normally I would check to make sure the database was created because I'm obsessive about that, but I know that this step will fail if it wasn't, so we're good to go. So psql-f data weather SQL, right? Telling psql with this -f file flag, execute this SQL file, do it by connecting to the weather database and running the SQL there. And Andrew, just like you said, all this seems to have worked great. So let's dive on in and see what we've got. Let's connect to the weather database. And let me go ahead and clear this console. So they're advising us to explore the database and familiarize ourselves with the schema, which is, I think, a great idea. We've got two tables, reports and stations. If we look at, let's look at the stations table first, because I'm guessing the stations make the reports, you know, if we were to make our entity relationship diagram. So let's see what's going on here. So this looks like a weather station, and it has a name and an elevation and a latitude and a longitude and an ID. Note that we've got some floating point numbers here with some degree of precision. I don't really care about the degree of precision, but it's good to note. Lat long coordinates, stations is a primary key, and we see that the reports are connected by a foreign key to the weather station. And I'm just going to look at all of the weather station data because this is a great thing to do too. Like, it's great to see the schema. Let's look at some of the data though to get a sense. And this is really helpful because, hey, both of my stations are airports, which makes sense, right? Airports are going to report weather data. You know, if you think about the assignment to work with some existing CSV files, it's not critical that these are airports and that's not like in our data schema, but it's nice to know. And we've only got two weather stations, so life is good, life is simple. And now let's take a look at reports. So there's a little bit more going on here. Let's make a little more room, in fact. Now I can see this really nicely. They have an ID, which they've used with this other way of creating IDs with identity that we saw. We have this foreign key that connects to our weather station. This already concerns me. I kind of went on my little rant about timestamps and time zones. The fact that there is a timestamp without a time zone type here already makes me nervous. And then we have double integers for temperature and humidity and wind speed and some just plain text information about wind direction, right? So just from looking at this, the wind direction, this data might be messy, or it might be text, but just really consistent. You know, and if you think about the pizza toppings, there from that 64 slices assignment, there's a world where the pizza toppings could have just been text. And then our primary key here is the ID, and we have this foreign key that references the weather station that this comes from. And there's not a lot of other constraints. Weather stations can have multiple reports. Each report can only belong to one weather station. Let's look at some of this report data. So there's a lot of data here. All of which appears to be from 2010. It's actually kind of interesting to look at the time here. I can see that this report happens every hour, right? 51 minutes, so this must be like 12:51 in the morning, past midnight. This is 1:51 in the morning, and so on. This is useful to see that we've got 24-hour time here. So this is 1:51 p.m. for the folks who didn't surf. Though I've been slowly getting more and more used to 24-hour time because it is pretty great. And these reports happen every hour. And this is why just looking at the data is so useful. And note that although these temperature and humidity values, and I think it was wind speed are doubles, they're floating point numbers. This is all integer values in here, which is great because it makes life simple. And we can sort of see the range. And this can be useful when constructing queries because I want to know when a query goes wrong. And if I don't have a rough estimate of what good data looks like, it can be very hard for me to know if my data is bad or incorrect, right? So just looking at this to get a sense of things is really helpful. That we've got this temperature range, 9, it seems to go up to 10, which would make sense for January in Chicago. Some sort of humidity index, some sort of wind speed, and the wind direction. That was, I believe, a text field, but we've got integers in here too, even though they're stored as varchars, as text, basically. And looking through this, I see 0 here and here. That's interesting. Are those real values? Something probably went wrong with the machines generating that data. We probably just don't have the data for that day, and maybe the Python code talking to our database inserted 0 or something because a value of a real data point of 0 seems unlikely. And if I just scroll through here just to get a range, I can kind of see, and I can see, let's see how much is in this table. Let's do select count from reports. With a lot of rows. There's 220,000 rows, which makes sense because this is every hour for a couple months, for at least January and February of 2010 for 2 weather stations. And we might as well group by station. Though actually, really, I need to group by was it station ID? And let's do station ID count. And let's expand this a little bit. This isn't a bad warm-up exercise, and this is kind of where we're going here anyway for average wind speed. Let's do select stations.name count star as num reports from reports join stations on reports.station ID equals stations.id group by station ID. And it looks like, oh, group by must be used in the clause or used as an aggregate function. We saw this before. Actually, can anyone remind me what a solution to this might be so I can see my station names and still do a group by like this? How can I modify this query?
Group by station dot name.
Exactly. We group by station name and station ID. And I think I can just say name when the column name is unique among all the tables that we're joining, I don't think we need to prefix it with the table, but let's see. Yeah. If station and reports both had a column named name, Postgres would have complained and I would have had to do stations.name. It's a pretty good habit to do that anyway. It's awesome. And actually here is in fact our sort of composite group by in action. So they both had a lot of reports. Chicago had about 10,000 more than Jacksonville. So we've explored our data. We've looked through it manually. We've looked at the schema. We've written sort of a query just to satisfy some of our curiosity. Let's look at some of these tasks that were being given. Which weather station had the highest temperature record? Which weather station had the coldest temperature record? And find the hottest and coldest record for each station in a single query, and finding the average wind speed. So this query here, this one looks like it's giving us wind speed. So let's write this out and run it, and then we can tackle these other questions, and maybe we can build these out ourselves. But since this one is right here, we might as well run it and see if we get average wind speed. And I think that's what it's doing, because if I kind of to talk through this out as we build it, select stations.name, reports.time, and there's this interesting double colon syntax happening here. And I'll look this up. Let's actually look this up right now. And actually, I'm going to remind myself the reports time column is a timestamp. So let's try ChatGPT. Let's see how good ChatGPT really is. Did it answer my question? If timestamp column contains values like, here we go. Here it is. I just got a little confused. So ChatGPT is kind of great. When we use, so this is casting, right? We've talked about casting a little bit in the class, casting a string into an integer, casting a string into a date. Casting is turning a variable from one type into another. So this double colon syntax lets us cast in a select query, and we're casting this timestamp column into a date, and then Postgres is probably doing some formatting and casting the date into a string, in fact. And this lets us only grab the bits that we care about, the year, month, and the day. So we don't need hours or minutes or anything else. And here we see a really simple example. And in fact, let's go ahead and just run a really simple example like that. Let's do select time, date from reports. And here we've got the date from this reports table. And if I had just done select time from reports, it would look like this. It would be the timestamp. So that we've casted that into a string. So let's come back to building this query and build it out. And we want to get our average wind speed. From reports, and we're going to join stations on reports dot station ID equals stations.id. And this group by and order by is interesting because we don't have column names, we have numbers. I'm pretty darn sure what's happening here is this is referring to the first column in our select statement, and this is referring to the second. But let's run this, see it work, and maybe ChatGPT can give us a little more clarity on this as well. And this gives it a useful shorthand, right? So I don't have to type as much stuff out. And that does seem to be what's happening. Though we have a whole lot of reports here for the station name and the date, and then the average wind speed. And it does seem that indeed group by 1 and 2, this is, excuse me, sorry about that. Our select statement is, you can think of it almost, it's like building a little table, right? Because it creates rows and the rows have columns. Each row is a result of our query. And right here in the select statement is where we tell it what the columns for each row should be. So here's our first and second column, which is name and time, which is a date. And we group by name and time. So we can see the unique combination of Chicago on one date and on another date, right? So indeed, we've grouped all the reports for one day into this row. So this is really useful to see because this is how we can aggregate time data, like to average it for a day. And we've got the average wind speed for each day. And this is ordered by, again, the name and the date. We see Chicago and we see these dates are increasing. And if we go through here, there's an awful lot of dates. Do we ever get there? We get to Jacksonville. And is this correct enough? It's a good question. Is this a good average wind speed? Probably. I don't know if we have any major issues here. My first thought would be about sort of the precision of this data. Some other thoughts. There's one thing maybe that could screw up our wind speed data. I don't know if any of you have any thoughts about like, is this number like a useful wind speed data? So I have a couple of thoughts here. The first is, this is way too many decimal points of precision. This is way more than I need. Like I probably only really need 1 decimal point of precision for whatever. We don't even have a unit here. And let's actually use ChatGPT. Let's get some degrees of precision here for our average statement. The average function calculates the average value. By default, it returns a result with the same precision and scale, but we can specify the desired precision and scale using the numeric data type. So this is another floating point type, and actually the one that I recommend using for most things. And here we can specify the degrees of precision, like 1 decimal point, 2 decimal points, because we're going to cast this. So let's see what we want to cast this to. The precision makes sense to me. The scale, I'm not sure actually the difference between precision and scale here. But but it looks like the scale one is the one that gives us the number of decimal places. So the scale is the count of decimal digits in the fractional part to the right of the decimal point. But what's the precision? And this is a little in the weeds, but this is also the kind of stuff that if you get this wrong, you end up with data that's not correct. The total count of significant digits for the whole number. So the number of digits, both sides, both on the left and right of the decimal point. So this number 23,54141 has a precision of 6 because we have 6 numbers. So this is actually important because if my precision is like 3 and I've got 2 numbers to the right of the decimal point, it caps me right here. So I actually probably want a bigger precision, but a smaller scale. So let's run this query again. And let's do a little bit of casting. Numeric. I'm going to say a precision of 5. I'll just say 6. Like the wind speed is probably not going to get over like 1,000 or something like that. And a scale of 2. I think we really only need 2 numbers to the right of the decimal point. So this is significantly more readable for wind speed and more useful. To be honest, we could even, I think this is still too many like scales. I would even argue for like a precision of 1 or even 0, to be honest, since our wind speed data is an integer to begin with. Like, do we really need more precision than already exists? Like, do I care about 15.78 knots or whatever? Probably not. I think that is actually makes more sense. So the other thing that I did wonder about with average wind speed is let's look at the reports. If we select wind speed from reports, I wasn't sure if we would see any zeros. I think there was maybe for wind direction, but there is for wind speed as well. So remember, the average sums stuff up and divides it. A 0 is going to dramatically mess with the average for any given day, right? And so I think that could mess with our wind speed data, or maybe there really was no wind on that day. Actually, maybe it was a completely calm day when it measured it. I'm not sure, but that did cross my mind. I think that might be really the only potential issues we have here. I don't know if folks have any other thoughts. Oh, and Brian, great call about casting to int. But I think this gives us a reasonable average wind speed. Is there anything I'm missing? I think the logic is good here. Cool. All right, let's build these queries. Oh, and Catherine, thank you. I think Accenture is on the Zoom, so I apologize. We didn't get that deep into this. We will pick this up, I think, after the resume coaching. These will be good ones to look at and that I will assign. I think you all should just try and tackle these. And then the other thing that we really want to look at is this stuff is cool, but I think it's pretty straightforward. Really, we're going to look at views after the Accenture talk because we haven't seen views, and views are actually pretty straightforward and super useful. So as a sort of look ahead, after Accenture, we'll do a little more with averages and things like that. But what we're really going to look at is, hey, I can use the results of a query to create a view. It's basically like a temporary table. And then I can use it to query other stuff. And that lets me compose much more complex queries more easily. So on that note, let me stop my share.